Okay, let's get started. We're at lecture 8, things are moving along. And we've been talking about dynamics and Newton's laws and how it relates to demand. And now we're going to make a big shift. And we're going to talk statics and strength of materials. So that's the engineering strain you see here. And we'll be talking about the economic analog to it. And in one word, you can summarize that with the concept of scarcity. Now, there are some economists who define scarcity. I forget who it is. It was Lionel Robbins, and he said something really deep about what economics is in terms of scarce resources and allocation. You can look it up. But the point is, it is a central concept in all of economics. So the feeling is that without scarcity, there shouldn't be any economics at all, because you can just get as much stuff as you want. So, do they see me with like a green bar underneath there, all frozen? Huh?
Yeah.
Oh, that's not good.
Yeah, something going wrong here.
Crashes.
We have a little technical issue.
Misschien een OBS opnieuw zetten.
Sorry.
Nee, dat is hem weer op de camera. En dan nu is het weer. Ja.
There he is again.
Okay.
Back to the studio.
Yeah, back in the world of the living. So, is the recording still on?
Yeah.
Okay. So, scarcity, and this is going to be related to springs if you make mechanisms or capacitors, if you make circuits as an engineer, and so that's the seal of it. So first, some of you do know. Does anybody know what this thing is here? A tally stick. Yeah, this is called a tally stick. You know how that's called in Dutch? Kerfstok. So, you know, we have the expression, iets op je kerfstok hebben. That is not good, right? So it comes from this, okay? So iets op je kerfstok hebben. Originally, when guys went to like pubs to get drunk, and they couldn't pay, so they would pay with for making a notch. And of course, if you then ultimately didn't pay, didn't settle your account, you would have to go to debtor's prison. So that was the origin of the term iets op je kerfstok hebben. So you got something on the tally stick, as we say in Dutch. And it means things are not good for you, so you're going to prison. So what these things were used for in the Middle Ages, one of the things of the Middle Ages, they were always short of specie. There was never money around. Money was silver. This was for the discovery of America. So the silver came from the same places that the Romans always got it. There was very little. The Roman Empire distributed these coins. I think in England, they were still using Roman coins like in the Middle Ages. So this is like hundreds and hundreds of years after the fall of the Roman Empire. Now, a lot of these coins will disappear. So you can imagine how little coins there were available. So if you don't have any specie, if you don't have any money, there's no way to have a market and buy and sell things, because buying and selling implies that you give somebody else money or receive money for in exchange for the goods. Now, if there's no money, what do you do? Okay? Now, what people did in the Middle Ages was they would make the deal, so they would give you, if you wanted some sheep, this thing is apparently for sheep, they would say, okay, here you get those sheeps, you know, you can just use them. I will record the fact that you have my sheep on this stick here. So they make these little notches here, and they record how many sheep. I'm not quite sure how it works. And then they write in this kind of a medieval script on it. what the deal was. So I kind of loan you, in a sense, the sheep rather than you buy it from me. And this loan is recorded on this tally stick. Now, what you want to do is, there are two people involved. There's a party and there's a counterparty. So there's the one extending the loan. That's the creditor. He has to believe that he gets his stuff back. That's the creditor. And then there's the debtor, the one receiving the loan, the borrower, in this case. And he's also party to the transaction. So both of them need a receipt for this thing. So what they would do, they would take this piece of wood and they would split it in two. And you could see this is the bigger half. This is what they call the stock. So in Dutch, stock. Yeah? In English, is stock. So it's like the root, the big part. And this kind of part, there was sometimes called, I don't know what it's called in Dutch, but they sometimes call it a foil. They can, or sometimes the stem. Now, when you split the piece of wood, it has these particular little irregularities. So later on, when the deal had to be settled, they could always match every stock with the stub and see who had done it. So the transaction is recorded twice. This one goes to the stockholder, and this was called the stockholder. So the person having this was called the stockholder. And this one was the debtor, right? So this business went on for a long time, and it is the origin of our word stock, like inventory stock, and also stock for securities. Since you're the holder of the stock, you have extended the credit to the company, okay? So in a sense, in the shareholder register, all that's going on is that you become the holder of this, the stock here, right? The big piece of the wood. And so the Dutch translation is almost clearer. It's just a piece of wood, a big one, okay? And somebody can look up to me what we call the other part, but I'm not sure. This is one from England. Okay? So this is what they used. They didn't use any money. They did use money, but very little. And there were huge amounts of these tally sticks around, and the Bank of England was in charge in England of, I already know about the English situation of keeping a track of these. Then I think in the 15th century, 16th century, I think it's the 15th century, they finally wanted to get rid of it. So they got them all together, they put a fire to it, and then they burned down the Houses of Parliament in Dubai, because they got so many of them. That was a big disaster. So this is interesting, right? So there's a lot of words here, like inventory stock, and we also talk of being long. So you got the long side of the bargain. That means this, and this guy's got the short side of the bargain. And in future markets, we still use this terminology. So you can be long commodity, like pork bellies or oats or wheat, and you can be short. The short relates to this part of the stick, the short part of the stick. Okay? So now we have an alternative to buying and selling. We have an alternative to the I element, or mass. We got something else. We got somebody who is long the commodity, who has it in inventory stock, or who is short the commodity. So that reminds me of a spring or a capacitor. Where the spring can be either long, so it is extended, or short, it's contracted, or a capacitor can be charged, then it will be long. It's a little bit harder to see how it's long, right? But it's easy to see how it represents an inventory stock being full, all right? And short means you're short on inventory, okay? So here's your inventory stock. Now, what people in the beginning were, this gets used a lot on what's called the future markets. Okay, so future markets is where all the commodities get traded. A lot of commodities get traded for prices in the future. So you make a deal today to go and buy so much wheat, but then in December, it's called December wheat. Or you buy it in March for next year, it's called March wheat. And so every 3 months they have an option cycle, and you can buy forward, it's called buying forward. So in order to buy forward and sell forward, on the other side you got people who are keeping stock of these things. So they're keeping stock of the oil, they're keeping stock of the wheat, or they're keeping stock of the pork bellies. Now, why would you keep stock of something? Well, it's just fun to have. Of course, you can have your shelves full of stuff, or a company like a grocery store, like a store actually. The word comes from the fact that it has stock. All right. So you store things. So a store may want to have inventory stock. Now, this is a big bother for them because they need to have a big building, they're going to pay money on it or this. But so why would they do that? Well, they would do that because there's a convenience associated with having the stock. And what, in their case, the convenience is the ability to sell it at some later point in time. If you don't have any stock and the customer comes by and says, I want some bread, you say, I don't want any bread. You know, you got to order it, right? You go, bye-bye, huh? I want the bread now. Right? Now, you may have your pantry, and you may have some apples in there or some breakfast cereal. I don't know what the heck you eat. But what's the convenience? The convenience to you is when you wake up in the morning and you don't want to go to the grocery store to get this stuff. You can just get it out of your pantry. Of course, you have to spend some money storing it and this and that, but you get a bunch of benefits out of it. Now, the benefit you get out of it is what is called the convenience, and sometimes called the convenience yield. But in the old days, the convenience yield was this in terms of money per item per, say, day of convenience that you get. So we see it as a force, right? So it's convenient to have these apples in storage. It's you measure it in so many euros per apple per day that you keep this thing in storage. In the old days, this was called the yield because it was like a crop yield. It was something that it would give off. But nowadays, we measure yield always in percents per item per day or something. So I'm just calling this now the convenience. So the convenience is a sort of want. It is a want. It tells you how much you want to keep the stuff in storage. All right? Now, the hypothesis is that this convenience is a decreasing function of the amount of stock you have. Now, this stands to reason. So suppose you're a baker. You wake up at 4 a.m. to make all this bread and these croissants and these muffins and all this stuff, right? And you're going to make so many of them. And you start baking, but you don't have any flour in stock. Now, that's very inconvenient because you can't make this stuff in order to sell later. So your first bit of flour you have in stock is worth a lot to you. But as you have more in stock, the extra convenience is a little bit less. And if you have hundreds and hundreds of tons of the stuff in stock, you don't even care anymore. You just want to get rid of it, right? So the first amount of wheat and grain and whatever you use to make this is, of course, worth a lot. And as you have more, the chances of a stock out just decrease. All right? Right, now, why did I use these baker at 4 a.m.? Because you can't go to the convenience store, right? Which is there, a store for your convenience to go get the flour because the stupid thing is closed, right? All right? So here we see a nice relationship between the amount you have in storage, so that's and the convenience that it yields to you, which is how much you want to have that amount in storage. Yes?
Does this also implicitly take into account the risk of having too much storage? Like for example,
yeah, or not explicitly. It's just the convenience of it. You know, we'll get to the risk later.
Yeah.
The risk is always associated with unknown. I mean, it's a really good question because the whole thing, in the literature, you'll see they throw everything in there in the bathroom sink, okay? So they'll put the cost of storage and warehousing in there. We won't. Okay? We'll put that in a resistor, an R element, because it has, in principle, nothing to do. It has also nothing to do with the items per se.
Yeah.
Right?
Yeah.
So this should just measure your personal utility of having it. You know, you can think of this, the slope of this, of how usefulness is, you know, so this is the spring constant, right? This is the usefulness. This is also the origin of the idea of utility. You just like having to have the stuff around. All right?
Yep.
That's right.
Yep.
So if you have a vacuum cleaner and somebody wants to come and borrow this vacuum cleaner from you, you know, they'll say you'll bring it back, you know, then you can say, all right, you know, will I do that? Well, I mean, it's worth to me something to have this vacuum cleaner around because I want to vacuum it. I won't be able to vacuum. So it's going to be worth something per day to have this vacuum cleaner around. But if I have a second one, that's worth a lot less. Okay? So it's just purely, and it's nothing to do with whether this thing breaks or not in principle. It's just to do with the fact of how many of these vacuum cleaners you want to have around. Right? Okay?
No.
So that's a good question. So it's very much like a demand curve, right? So here you have the price, and here you have the quantity demanded, all right? And as you increase the quantity demanded, the price drops. But this quantity demanded is a flow, right? And the price will then be. Whereas here we have a relationship between a stock variable and then a what? A force. Right? So it's a sort of alternative to buying, is borrowing this stuff. But if you borrow or loan it out to somebody, this is I guess it's the borrower, right? So for all you Dutch speakers, you know, don't confuse loan and borrowing, right? Don't use the word loan for both, right? And borrow is what I do when I get it. It's just alternative. Rather than buying, you can borrow stuff, and rather than selling, you can loan out stuff, right? And then there's no sale taking place, so there's no I element at the site. There's no demand, really. You can think of this as demand for stock, but that's a little bit silly. It's more the usefulness of it, okay? All right? So you see there's something fundamentally different, but you can still solve your economic problems with it, and you'll need a lot less money. All you have to do is pay this little thing out per period, you know, rather than pay the whole cost basis for the investment in this vacuum cleaner. It's like renting a car rather than buying it, right? So the sharing economy that they talk about is based on the convenience yield, all right? So something fundamentally different. And that's what a spring is. It's something fundamentally different from a mass, right? So let's now investigate this business, okay, and see how it all fits in with the mechanics of spring and the statics and strain and etc. All right? So everything is clear for now. Oh, and then I'll advance the slide. Where is the slide advancer? You know? Ooh.
I don't know. Here's the key.
Oh, here it is.
Dat is eentje terug.
So the first thing we need to do is get this thing in a little better shape, this little curve. That's what we did also with the demand line. We had to give it a flip because things were sloping down rather than up, and the spring stiffness is a positive number, okay? There are no negative stiffness springs. You have them, but they're weird, right? They put energy in. Is that right? I don't think so. Is that right? No, it is right. over there. So what you do is you need to get a point of zero, right? So you'll have an inventory at which the convenience yield is zero. This is what you find. And that's your zero level for your inventory, okay? Your zero stock level, all right? So when you're indifferent between loaning it out, a very small amount, loaning it out or borrowing it, you know, it makes no difference to you, all right? So you're here at zero. And so if this is the zero on the, if this axis is correct, this will be then the desired inventory, right? So this point will go over there. And then what this thing measures is apparently we have to give it a flip. So what we're measuring is not how much we have in stock, but how scarce it is to me. How much? So we'll just measure this distance and then flip it around. So rather than our stock level, this thing is measuring the scarcity of it is. So the scarcer it is, the more convenient it will be for us, of course. Right? So this is this baker, and you can see at a certain point, he doesn't want more stock anymore. Then he's actually an oversupply. This will be the, he will have an abundance. Huh? Will be in the negative side. So I just need to get rid of it. Right? So the terminology is also associated with this is the short side, this is the long side. Okay? So that's just our usual little trick to get things fixed. This is known as the relative scarcity in the literature. You also have something called absolute scarcity. All right? Now this thing is supposed to be, you know, like a spread, right? So here I have, I've got two figures here. This is the stress-strain curve, just this thing you can get from Wikipedia, so you can see the elastic region and then the plastic region. And these are futures price spread. They use the price spread. This is also called the basis. We'll talk about that. And that is the spot price minus the future price. So that's the negative of P dot dt, right? It's just a little impulse, but it doesn't matter. Really what you're measuring here is the difference between the two, all right? So this becomes, this is the convenience yield here. Let's call this F for the convenience yield. And then don't worry about this point of zero here. They shift it around a little bit because they subtract the interest rate from it. So they look at the negative of the convenience yield and they add the interest rate. So they kind of flip it around. Everything flipped around a little bit. But this is a typical thing you see. This is from one of the founders of this thing called the theory of storage that they use in future markets, this guy called Brennan. He's got a bunch of these. Interestingly enough, this is pretty old. And you see, this was from the 50s or something. You can see the guy with his typewriter. And in those days, they were more concerned with economists with actual data and actual applicability. Nowadays, you'll see economists are mostly theoretical, okay? And they wouldn't fit these relationships. So this is one for wheat futures price spread, okay?
What does it say on the axis?
This is stock, S of T, stock at time T.
And the other one?
This is the interest rate minus the convenience yield, okay? So you see, we have here the plus the convenience yield and minus the stock. All right, so there's a little bit there, but it doesn't matter. Huh? It's just the way we choose our axis, the whole thing is going to come out right in the face plane. That's the reason I do it different. But you can see this is just the right thing. So to me, this is like stunning. I mean, so you can move this thing around. This is just the interest rate. So it's just a point of zero that is a little bit different. I wouldn't add on the interest rate. You know, that's a separate thing. They somehow never separate these things. Okay? And so you see, it's quite stunning. I mean, here you got the elastic region, you got some plastic region, and maybe here's where your inventory breaks up entirely. You're completely stocked out. So to me, this is a nice fit. He says all these, they all end up on the same way, you know? So the convenience yield is rising and rising, and then at a certain point, you know, it all makes no difference anymore. All right? So conceptually this fits, but for me also what is surprising is that the data shows that this also fits. This is more important than the conceptual thing, you know? Because this data, you know, you don't know what it is they're really measuring, okay? All right? So these kind of things there, I don't know what, they don't have a name for the slope, so maybe the usefulness or something. You could go with the utility or the marginal. This is the names that they use for so many other things. Yeah? So it's a little bit, they have something called rigidity, which sounds like it's close to stiffness, but it really isn't either when you're out. And it should really be the elasticity, but the elasticity is also used for the inverse of the inertia, typically, okay? So it's just a big mess, these constants. So it would have been nice had we been able to use the word elasticity for this thing, or the inverse of this slope. And then, but we can't, because everybody will think it's the price elasticity. Although these economists will think of this could be the convenience, you know, the stock elasticity of the convenience yield or something, you know, now, but it's a mouthful and they never use it. Okay? But they do use some other stuff that we will see on the phase plane, all right? And they'll also use this factor here, which is, we'll see that. Okay, this is the business cycle. So that's the situation. All right, so this is actually, you know, you'll be surprised how long it took us to figure out that this is the analog. And when you hear it, you think, okay, well, whatever, right? This is obvious. All right. So now what I want to do is get this whole vector analysis stuff right. So this is a little bit of a picture that takes a while. I'm pretty bad at these kind of things, so I lay them out, I do them once right, and then afterwards I get confused again. But I think every engineer is like that. You know, what is a positive force? What's a negative force? Somehow you always kind of do it right in your head when you make the picture. And then, but when somebody asks you to write the equation, you get the negatives and the positives confused. So let's just try to go through there. And maybe I've made another mistake here, but at least you'll see there's a way of systematically doing this, assigning positives and negatives. So you remember how we did it with the man? We would, this is not a mass now, this is just a point where you're at. But then we would have a mass that will have a positive direction, the setting direction for the quantity demanded, and then for the price was positive in that direction. Now the situation is quite different because we're not selling anything. So we can have a sort of stock level, which is the neutral level. So I just drew that right here, all right? And then as you move to the right, you're loading out these stuff, right? So you're doing the thing that corresponds to the selling, except you're not selling, you're just loading this out. And as you're loading it out, you have to apply this convenience yield, all right? So the borrower has to pay me, you know, per unit, per time, this convenience yield for me to entice me to load it out. So in order, if you think of the inventory as a spring, right, then it's clear that the spring, the force that you apply on the spring, that's this thing, that's got to be a credit. It's got to be a positive force, pulling this string out to extend on the long side. All right? And then the load quantity, the amount you're loading in, so this is like load in, huh? This is borrowing, so I load this, huh? So that's a positive then as well, all right? And as I do that, I become a creditor, right? So the positive side here is the creditor, the positive side from the moving thing is the load in, and the force you apply here, the economic one, which is the convenience yield, that's being credited to me. That means it's income to me. It's credited to me by this one who is debiting somewhere. Here's the reaction force. It's for him and it's an expense. Okay? So actually the picture, and then this thing is then about the scarcity that you have. Or the, right? So you can see maybe this isn't so difficult, right? It always takes me forever to see this, but now that I explain it, I see everybody looking like, okay, well, all right. But notice something, that what's happening here is quite different than the theory of demand. Like, the theory of demand had to do with inertia, and we had an inertial reference frame. In an inertial reference frame, every point in space is the same. It doesn't matter where you move your apparatus. That's not the case anymore. This point is special. Right? And if I had a spring this way, that other point will be even more special, right? Everything wants to go back to this point, okay? That's the desired inventory. So all of a sudden, my space gets a structure, okay? There's a special point, which is the point of desired inventory, which you could call, in a sense, the equilibrium point, okay? But now it's an equilibrium concerning the stock variables, all right? The stocks you have, not the flows. So we're not in this kind of demand equilibrium where we're going at constant speed, which is more like a rest, what we would call rest in mechanics, but we're now sitting in this stock equilibrium, right? Which is what we would call in mechanics real equilibrium. Both the speed and the position is at the 0 point, okay? Of course, we define what the 0 point is. You can put it any way you want. All right? So strings, like storage and scarcity, introduces a structure in the space. Okay? So where you are, if you think of this as actually where you are becomes important. How far you are away from that. All right? Now, if you do this and you take away the force, this thing is going to slam back to 0 in no time, which is really not possible because it has to go with the speed of light. But that's because we don't have any masses now on this thing. All right? If I put a mass on that, and we all know what's going to happen, it's going to start oscillating. Or if I added a damper, which we haven't treated yet, it would just go slowly converge to this point of equilibrium. All right? But nevertheless, you'll just see this is a load. You move the other way, you're borrowing, you would be debiting. Okay? And if you go past this point, you would become a debtor. Right? So you have to see that you can still be a creditor and be debiting. You're just building down your credit. You're just using up your credit. You can be a debtor and be crediting, okay? Because you're paying off your debts, all right? Okay? So we have now a situation where not only your position matters, whether you're a debtor or a creditor, but also how you're moving, whether you're debiting or crediting, where you're paying off the debts or or investing more, or going the other way. All right, so we have 2 times 2 is 4 combinations. We'll see how that works out. Okay? Any questions about this? Or is this just trivially clear, all of this? It's trivially clear, huh? I'm surprised. Because it takes me forever to sort this out. And sometimes you guys don't get it, sometimes I feel it, it just seems that's fine, right? It's a little bit the problem with the stuff. When it's fine, it's kind of really fine. You wonder why you ever had a problem with signs, And then, anyway, you can be quite confused about the science with this, no? And in bond graphs, this is really hard to see, what is positive, what's negative. You really have to, sort it out in these kind of spatial diagrams, taking into account that there's a positive and a negative direction to the right and to the left, and a positive and negative position which is to the right of a particular line or point, or to the left of a particular point, right? So there are 2 notions of positive and negative, all right? And in terms of the goods, the loaning or the selling is the positive direction. And for the money, the crediting is the positive direction. And the borrowing or the debiting are the negative directions. Or in this case, it would be buying, right? In the other case, if you have an iron goods. Okay? So here, I have the same figure, but now I added, instead of that point, I added a mass, right? So I added demand here. And I have, it has a price, positive price, so it must be a seller, right? Because it corresponds with a positive quantity demanded. But as it is connected to this spring, okay, to the storage, this quantity demanded is now equal to the change in the stock, okay? You see that? That is something that you didn't have before. Before, we would always be writing this, and I would purposely not write this in there because there was no stock really to figure out if the change in the stock was equal to the velocity, the quantity demanded. But now it is, right? Because we can measure the length of this, the extension of the spring. So we can measure the change in this Q. So there you go, right? So attaching, if you now have a seller who's selling out of storage rather than loaning, you find that the change in the stock level is going to be equal to the quantity demanded, okay? Similarly, you will see that the force on the mass, which is the reaction force to the force we have to put on the spring, okay? So that is the convenience yield. How it relates to the price is going to be the negative of the price movement. Okay, that's clear. This is what we did in general last week. But we know that this convenience yield is equal to K times Q. All right? Did I do that right? No, it should be the positive side here, right? So, yes. Whatever. Doesn't matter. Yes. So we get that. Yeah, so I did this wrong because you have F is equal to, we have F both equal to the negative of the price change and simultaneously equal to the, proportional to the stock, right? So this should have been a plus sign. Okay?
Oh, wait. What direction are you measuring Q positive in now? Because if you take the P is M Q dot in that direction as well, then it should be a minus.
Yeah, this should be a minus.
Because if you're measuring Q to the right is positive, just like P is Q dot, then only the F to the left.
No, this is the positive Q, right? The scarcity is, I think it's like this.
But then the Q dot's the other way around. What? What way is positive P then?
Yeah, I got myself confused now. Yeah.
What?
Yeah, what? Yeah, so this should be the scarcity. So this is the reaction force. So this force here is minus F, right? And that is minus KQ, and that should be equal to P dot, right? That's how it works. Right?
Yeah.
So that is right. So you could also write it like this. This would have been better. This would have been clear. Yeah. So a little bit confusing because we're now not extending the spring, but we're decelerating the mass, you see? So I'm looking here now at the reaction force, which is the negative of the force, that you have to, that the mass applies on the spring. Okay, so I'm debiting now here, debiting. It's still confusing, but once you got it right, and then you get it wrong again. But I have the same problems when I make these diagrams. Is this force now positive or negative? Well, then you have to think really hard about what's going on every time, right? I can't somehow reason through it just purely I can do it purely mathematically, and then I have to be very careful to make a free body diagram of this thing or a free body diagram. I mean, but I think this is right.
I think so too.
Yeah, I think so too. Yeah. I'm terrible at this. I told you, I'm terrible at it. Once you get it right, it's all obvious, and then you get yourself confused again. We usually do a bad job, you draw these free body diagrams, you just kind of make it up, and then on an exam you get it wrong again. Okay? So, there's a couple of interesting things we can see here, is that we can now see that the price movement is equal to the negative of the convenience, right? Okay? And we can see that this quantity demanded, because of this equality here, we can see that the inflow into the stock inflow is equal to the price divided by the inertia. All right, so this is the price times the elasticity, because this is equal to the quantity demanded, right? Okay. So from this little picture, we get two important equations telling us what the movement of the funds is like, the money is like, and what the movement of our stock is going to be like, right? These equations have a name. These are called Hamilton's equations, by the way. We'll get to that when we do energy. But basically, they contain the equations of motion. Because if you if you differentiate this thing, and then you got P double dot here, you get a Q dot, and you plug this thing in, you can get a differential equation for P. And if you integrate this, and if you differentiate this thing, you can get it's easiest to differentiate this. So then you have Q double dot, and then you just plug that in there, so you get Q double dot times N is equal to minus KQ. So NQ double dot plus KQ is 0. So you just get the equation of motion. Okay. Now, in the future markets, they usually don't deal with this price movement. They deal with what they call the basis. So that is the negative of the price movement dt, right? But this dt is often, they have trouble because they're trading futures like December and then in March, I believe, and then every 3 months. So this dt is 3 months out, okay? So it's a big dt. And then other markets will use a shorter time or a longer time. There's no standardization. And so the CDOT uses these letters of these different expirations, and then you roll it over. You go to the next one and the next one. So that's what you do. So if you're at the December, you start rolling over to March, and from March you roll over to December, September. I don't know. I can never remember. But future traders will do this. All right? This is what they call the basis, and they'll talk about how this basis is changing. Yes?
So can the terms futures and forward be used interchangeably?
No, not really. Almost. A forward is just the price is forward. Okay? And a future is a contract to buy at the forward price. Okay? So it's like a loan and a bond. Okay, so a loan, I loan you some money, is this fact that I did it. But a bond is a contract that stipulates the conditions of the load, all right? And that's the same difference between a futures and a forward price. So I call this forward pricing, but this is what's called the basis of the future. So there'll be a future for December delivery will be this DT here, right? So this will be the basis of the contract, you know that. It's a small difference, okay? But if you look at the future markets, this is how they reason.
So isn't this just a discrete approximation then? If the DT is actually, say, a delta T?
Yeah. I mean, not really, because even that doesn't really work. Because if here is January, then here we'll have March, you know, and then, you know, the beginning of January, this is DT, and here, this will be DT, because,
Oh, it changes.
It's sampling.
Oh.
It's not
Yeah.
per se
yes,
Okay.
discrete time system, like you're sampling.
sampling, yeah.
So
And they
it
know
changes.
that, and they'll say, oh, you gotta correct them. They'll correct with the interest rate. They'll try to correct in some way.
Okay.
Okay?
Yeah.
So it's what Koen says, it's sampling rather than. So the idea is really a small DT, except they can't trade infinitely many stocks. So the more liquid the stuff is, the closer you could have the expirations, you know? Yeah? Okay? Options are traded the same way, right? So you get an option, it's the same thing. You just have the right to do something in this period, but the thing is like you're reducing all the time. Right? So if we do this kind of engineering analysis, it's better just to deal with P dot, okay? Just the inertial force, right? And then when you have a real market, you kind of have to do what Koen says, figure out the problems with your sampling and all of that. Okay? So they'll use convenience. The convenience is more in theoretical discussions of forward pricing. And in the practice, people use this word basis. It comes from the cost basis, right? So because this is like what you have at risk, right? So if you take a position here, you have a spot, this is what they call the spot price, this is the forward price. You know, this would be your basis risk. If you sell spot and buy future, or the other way around, this is really the basis of which you're doing the trade. This is very interesting, you know. Nobody's ever done a thesis on this yet, but the future markets are just, there's a lot of data available. It's definitely amenable for a nice study from an economic engineering perspective. It just hasn't been done by anybody yet. Okay? So, I think what I want to do is then go to the trade cycle with this, but it's better to do that, I think, after the break. You know, then we'll take this situation and we'll start analyzing this in the trade cycle, and then do some fluctuations. I got some data, talk about the business cycle, and so we got 3 slides. So I'm getting more done now than I was planning to. I thought it was going to take a long time. So I'll just leave it here so you guys can take a look at this. And the crowd here is going to get a cup of coffee. Okay, so let's get started again. I got a question during the break about the exact nature of the convenience yield. And it's important, if I presented this like this, it all seems very clear, but it is not so clear what is exactly the convenience yield, and that's not so clear to us, and that's also very, very unclear in the literature. You know, there's a lot of discussion about what this thing really is. But one thing that what you should always keep in mind is the convenience yield is a function of only the commodity that you plugged in here, right? So the convenience yield on the ith commodity is a function of the ith commodity, okay? Explicitly only that, okay? There are no other stuff here, all right? And if there's only other stuff, it's also wrong, okay? So they have another thing that is used much more, and it's called the cost of carry. So that's the total cost of carrying stocks of inventory. Now, in the cost of carry, they have a plethora of stuff. They have insurance that you pay on your stock. They have warehousing fees. They have spoilage, or interest foregone because you borrowed the money, and that's the opportunity cost. A huge list. Now, if you think of warehousing, you would think, well, that's a function of Q, but it really isn't. The warehouse is just the warehouse. You just pay this amount for the warehouse, and it could be a function of you could store pears in it instead of apples, and this is apples. So it really isn't just a function of Q. It isn't. It's just a fee you pay per warehouse, okay? And insurance also, you can say, well, it's done in per apple, but that's not the point. The point is it's not a function of these apples alone, okay? No, the convenience yield is the convenience you get out of that thing, irrespective of how it's stored, insured, what your opportunity cost was, interest rate, we don't care, all right? It's very important to keep that in mind. Now, we haven't treated the R element yet, and the R element we will, but it's a way of, when you have degrees of freedom or Q's that you haven't modeled, you can just kind of throw everything in an R element, all that stuff. So everything that's going into degrees of freedom that you haven't modeled is really modeled with an R element, okay? This is similar to how a damper works, right? So a damper, you'll just push it in, and then, of course, you think, like, where did the kinetic energy go? Where did the momentum go? Well, it didn't go anywhere. The kinetic energy, it started taking all these individual oil particles, and they now have a lot of high speed, and that manifests itself in terms of the temperature going up. But are we going to model all these things? No, we decide we don't, okay? And that's what we call entropy, all right? So this will be our R element, but it's not true that everything that is not in the convenience yield, but in the cost of carry, is necessarily done with an R element. It could be, that you're slowing this thing down with an electric motor or a dynamo or something, or generator, or you're lifting a weight in another dimension, so you're buying other stuff with it. You're doing some transformation, right? It's not true that every force is necessarily, that you haven't modeled in a spring is necessarily a damping force. Now, it could be all kinds of forces, and that's the same with these ones, okay? So it's good to keep that in mind. Why? Right now, I just want to focus on the C element, okay? So this is just what they call the convenience yield, okay? All right? Now, the basis is more general. That's just a general difference in prices. In this case, the basis will be equal to the convenience yield because it's the only thing we have lying around is the convenience yield, okay? Right, so the difference in momentum will all be due to the application of the spring force on the mass, sure, right? Okay? So the basis is a slightly more general concept than that of a convenience yield. It's just that we only have the convenience yield now, right? So we're going through this step by step by step. So first, only inertial elements, only demand, all right? And then some arbitrary force, there was a handling fee, some fee that I used in order to show how can this change. Now we have a specific way in which the price can change through this convenience fee, okay? But future markets are more complicated. They will have the cost of carry, all right? So this market here is also a future market in no carry instruments. So instruments that don't have a carry. So, securities are such an instrument usually, then, it doesn't cost anything to store them. They don't really go bad, and all this stuff. You don't need to insure them, You do have to, and interest rates are zero, so the money doesn't cost anything, right? So securities would be, zero carry, and this analysis here, especially in the current interest rate environment, is a good approximation to how securities move. And we'll see that it's going to be quite fluctuating, which is what we see, okay? As interest rates have gone down, and then the cost of security transactions have gone down, and the cost of, you don't need to have any custodial fees, they call them. So that's the fee you pay your broker for just holding the securities in your name. Okay, those are also approximately zero with discount brokers. So no custodial fees anymore. Okay, so they are what they call zero carry, but with a convenience yield. The terminology in the future markets is really confusing because they call everything a cost of carry. We'll also see the convenience yield works in a very different way than the other cost, okay? And you know that. The spring force will be proportional. The spring force is going to be proportional to the extension of the demand, the acceleration, all right? Right? But a damping force will tend to be proportional to the velocity, quantity demanded, right? So they will show up in very different ways. The spring force will tend to be orthogonal. The solution will be a sine wave rather than exponential decay, all right? Now this they don't have, all right? So they just add the sine wave to the exponential decay, but they can't think of sine wave as being modulated by an exponential, then the amplitude is decreasing. They just add them up, and then the thing will have to turn around. Basically how the IVM does it with coronavirus, right? So they can't make the difference between a gradual decrease in the infections and the cycles, all right? So what we would do, we would say, okay, the infections go up and down, and at the same time they're decreasing, so we'll have a complex R value, right? One gives you the modulation and the other the fluctuations. But they don't do that. They have a single R value, and they say how the R value is changing on this moment and that moment and that moment, and now it's going down and then it's going up again, all right? Now this situation is the same in the future markets. They don't have these complex rates, okay? So keep this in mind. Okay, is that clear? Because I got a bunch of good questions about this. And I actually got one. But is this made it clear then also to you? What's going on here?
Yeah. With the complex noise, with the convenience and cost of carry, I'll have to think about it another time. But.
So the convenience is on the imaginary part. It can't be but there, right? Okay, because think about it. It's going to be a force that will give you an acceleration, right? That's got to be a complex number because it's a sine wave, and you can only get a sine wave with a complex exponential, right? An imaginary exponent, okay? But now think of the cost of carry insurance. That's not going to be sinusoidal. Of course not, right? So it's going to be on the real part. Mm-hmm. So there you already have a big difference.
No, this difference I get. I was referring to the part before that, but you've already moved on. But one thing, you said that the spring force would give an acceleration. I mean, any force gives an acceleration when you plug in that equation with the mass, right? But that doesn't have anything to do with the spring on the top.
Yeah, but this force is K times Q, right? Yeah. So what you'll get, this will be the equation of motion.
Yeah, exactly.
Right?
That gives a sign.
Or you'll go This is going to give you a complex exponential because of the.
Yeah.
But now you plug in a damper. We haven't done an R element. There'll be some B and a dot here, right? So you integrate this once, you'll see, you get a first order differential equation. Yeah. So you see, the cost of carry can be very different. What's done by an R element, huh? And now suppose I just put a constant here. All right, then it's different again. It will shift it, right? Huh? Okay. So that's what I mean. So if you take out of the cost of carry, if you take the damping and you separate it from the convenience yield, you'll see that some will go. So you'll get this equation of motion, huh? And here's your convenience yield because this is your stock. But this thing's going to depend on the flow. All right? Okay? But both are in the cost of carry because both change, the extension of your demand will depend on both. Okay?
Yeah. The thing I'm struggling still with is the reason why you would put the cost of carry on the left one and not on the right, or the convenience on the right and not on the. I mean, the convenience I get why it's on the Q and.
What do you mean by? Oh yeah. We'll have to.
Equation,
yeah, we'll have to get to that when we do 0 junctions and 1 junctions. Okay. But the short answer is this, right? Let me just say this. There's 2 ways to do this, right? You can put. Okay. Which one did you do? So there's 2 ways the cost of carry. So you have, this is the convenience yield. And there's 2 other ways in which you can put dampers, right? In order to supplement the cost of carry with all these other costs. What does this one do? This one's, this damper, it takes up part of the stock, right? So you're moving, you're buying, right, or you're selling, but not all of it goes into storage. Some of it gets consumed physically, right? Yeah. Okay. So that's like a rotting of the apples, or I don't know what's going on, right? But this thing is different. If you take out this damper, everything will go into stock. But here, the momentum will change. So the price won't be what you want. So this one is discounting the price, this damper. Yeah. Well, this damper is discounting the stock, all right? So this is a depreciatory damper, and this is a depletionary damper, depleting, okay? So that's a big difference, and you've got to keep those apart. But again, we'll get to the hour element. But I nevertheless think it's good to answer this question now, because to understand what this spring does, it's good to know what these dampers do, right? So the assumption is that this little rod here is rigid, right? It's not just like losing position. And that this thing's open. There's nothing here. Okay?
Yeah, that's right now with just the convenience and not the cost of carry.
That's right.
Yeah.
No other cost of carry. Right?
I'll be patient until the dampers.
Well, impatience is also good because it's sometimes good to look ahead, to clarify. Because one of the problems when you just learn this, you go like, okay, well, this is all clear, right? And they apply, and then you got all these other forces, right? So I'm kind of happy to make this detour, But you're satisfied now to some degree that you know. See, that's the thing. When you say convenience, you better know what it is, right? When you say spring force, it better be a spring force. It has to depend on the position. It can't depend on the velocity or other things, okay? Then it's not a spring force, all right? And only that position, if you have a force that depends on some other position, some other space, it's also not a spring force, okay? All right? Good. All right, so So now we have two state variables, right? So we have the scarcity, that's a state variable, so we can keep track of our stock, right? And how it deviates from our desired inventory stock. Yeah? And we have the amount of funds available, and the money we committed, the price. And so we have two variables, and both of them are changing, right? This one is changing, and this one is changing, right? And we both know the laws of which they were changing. Now, normally in engineering, you would say that this system is happening in what we call phase space, right? So there's the space of an axis for the positions and one for the momenta, right? Sometimes, especially in engineering, we won't look at the momentum, we divide the momentum by m and then look at the velocity, but it's a little sloppy to do so, right? You can do that when you do Lagrangian mechanics, but not this type of stuff, okay? Yeah. So, what I want to do is take this situation and analyze it in phase space, all right? So, boink, here we are. And let's just take, there's a lot of colorful terminology that's being used in the future markets. Future markets are really old, okay? And there's a reason, because farmers needed futures, you know? They needed money now to buy seeds, then the crops would come later, you know? So they would want to sell their crop forward, you know? So they get somebody to lock in a price, etc. I think they were, in the West, they were developed by the Dutch East India Company, as everything else was developed by the Dutch East India Company. So the first future markets was in Amsterdam. And it was taken over by London, you know, when the British Empire kind of ruled the world. And some of this terminology, like contango backwardation, comes from the LIFI or LIFI, whatever it's called, you know. And now it's basically taken over by the CBOT, the Chicago Board of Options, Chicago Board of Options Trading or something, for the whole world. And there's some terminology that's associated with it. And what I want to do with this slide is go through that. Right? So remember, we have two variables. We have the scarcity here, and we have the price over here. And actually, what I assumed here is just m in this case. Let's make it easy so you get a nice circle. And what you recognize is the phase portrait for the harmonic oscillator, right? So why is this the case? To see that it's conserving energy, we won't do it this way. We'll do that a little bit later. But you just recognize here the two equations that we were from last night. So this is the inflow, which is equal to the quantity demanded, and this is the price movement, which is the negative of the convenience yield, right? So P naught is just a vector along the price axis, and the negative just brings it down, right? The inflow is along the, this will be the outflow, right? It's along this axis, and this one is proportional to P, and this one is proportional to Q, okay? So if you compose the two vectors, you get this vector, and this is called also the Hamiltonian flow, right? Or the phase flow, let's call this the phase flow. So we think of this as the point, this is the configuration, this is the pendulum, it has this momentum, the bob, you know, so you can think of a simple pendulum, right? Or well, just think of a spring mass system, huh? You know, so this would be the momentum of the ball, the mass, and this will be the velocity, the position. And if you go through these tangent lines, you'll see that they're tangent to a circle, okay? Right? Now, at every point in time, you can kind of see what happens here, right? So here, what's happening is like selling like there's no tomorrow at a high price. Huh? So this thing is selling at a high price. Around here, he is debiting like there's no tomorrow, but he's not selling anything. So the money is flowing now, okay? So he's debiting, So there's a lot of expenses are being made. Here he's buying, he's crediting, and then he goes back to selling again. And there's some phases in between. All right? Now, this part, you see the price is dropping. Did I get that right? Is it contango? Contango is the, I think I got this wrong, actually.
Contango, the price goes.
Contango, does the price go up? Can somebody quickly look it up? Contango is, does the price go up in contango, or does the price go down? Huh?
Contango is a situation where the futures price of a commodity is higher than spot price. Contango occurs.
So that's right. So here's the spot price, and the futures price is higher, right? So this is spot, and this is the future. Huh? Okay? I won't use F. Huh? So this is the price, the spot, huh? And this is, that's right. So here is in contango, all right? So here they're contango, here they'll switch from contango. So you see why they use it the basis, right? So you can subtract this, and that will be the basis, right? But it's better just to look at this vector, right? This thing gives you a much better idea of the basis, how it's changing. So when the force is decreasing, we say that the spot gets stronger relative to the future, right? Then the basis is strengthening. And when it's going like this, the basis is weakening. All right? So they look, when the base is strengthening, they look at the convexity of the curve, right? So this is the motion of the force. Did you see that? So this is the area here.
In the top part, you're reducing the amount of stock, right? Or not?
The basis is the convenience yield, right? Is the negative, right? Okay. So it's a future. So the spot minus the future, right? And future minus spot. That's the divided by time is the force, right? Is the convenience yield. So the basis is the negative. So what they do is they look at the spot and the future. You look at this difference, and when this is moving faster than this one, the basis is strengthening. Okay. So it is a measure of the convexity of this curve. Okay. This is just a terminology used: basis strengthening or basis weakening. And this is how these traders. You can look at, you can read these articles. You get totally confused, but if you use this little graphic here, you got yourself basically straightened out. Okay. So you'll see that in a situation like that, if you don't have other cost of carry, the market is switching between contango and backwardation all the time, right? So either prices are rising or prices are lowering. And what you can do is you can buy low and you can sell high, or you can loan out when you get a lot for it, or you can borrow when interest rates are low, right? When the rate is low. Huh? Okay? So you can see here the different phases that a trader would go through. Is borrowing, is loaning, is buying, and is selling. Okay? Now this is entirely analogous to how a harmonic oscillator would function, right? This is very satisfying to see. I find this pretty. I've never really traded future markets, but it takes forever until you get these terms right. And when you see them writing about it, it's worth your while just to look at it. You'll see that they somehow got it in their heads after a while. The only way I can get it in my head is just to look at the equations of motion. I mean, it almost feels that this is an anticlimax, but you should see that we kind of have achieved a lot right? We're thinking of harmonic oscillator. What has that got to do with anything in economics? And we've just argued ourselves all the way to commodity markets. Here is a graphic of crude oil forward yields, okay? And you see that, now. So they even it out. You get a lot of noise, of course, right? There's a lot of crap happening, all kinds of weird demand or bad harvest. But if you even it out, you'll see a nice, a nice natural frequency occurring.
So you would argue that if not much is happening, say that there are no special circumstances, no external forces doing something weird, then it just follows the cycle and that's it.
What we call the trade cycle. And it will depend on the usefulness of holding stocks, right? And the elasticity of supply or demand. If you fix those, you know what the trade cycle is.
Yeah, exactly. So when I look at the graph, of course, the cycle changes its frequency. On the left, it's higher frequency. On the right, so there must be some other forces, you'd say, that change that.
Yeah, or maybe it's not a simple one harmonic oscillator. It's got, now maybe, now this the different types of storage. I don't know, all kinds of crap, right, going on. Right?
Yeah, so they induce different forces, right? These other oscillators. Yeah.
So, but these will just be, if you have a more complicated transfer function, I would just look at the poles or something, right? Or you have a complicated system, I would just look at the different resonance frequencies that it may have.
Yeah.
Huh? If it's a second order system, it's just going to have one resonance frequency, but otherwise you just take a Fourier transform, right?
Sure.
Now you see there's a little bit of an average down like this, so you got to take some out, but all of that can be fixed. This was a nice article because this is very recent because commodity prices have been very volatile recently, okay? Because they pumped a lot of money into the market with all this coronavirus relief efforts, and at the same time, trading costs have gone down, so we see huge fluctuations in commodity prices. Now they're going way up, So we had Shell here, and they can't predict oil prices, So they have this whole system of cost of carry and this, and it never seems to work. But I think if you would take it from a more fundamental point of view and look at the convenience yield, you'll be able to explain some of these current.
That's also partly because of the demand that is going to pull all over the place.
Yeah, so that may be a problem, is that you have a lot of weird shocks to the system, but still the system is what it is. So if you take a building and you hit it at all the time at the right frequency, it's going to pick it up and it starts amplifying at that frequency, So sure, you don't know what hits are coming here from the outside, but the market itself can be modeled, this is crude oil,
So how do you then quantify K?
I don't know, right?
Because that's
you just have to look at, what I would do is I would look at this frequency,
So you try to find either K over M, or maybe you can find the elasticity in the literature.
Yeah, so you need some form of data or literature. Because I'm also looking into that for my thesis.
Yeah, so typically what you want to do is the kind of data that you have available is production data and price data.
Yes.
So that's what you want to put into your model. So the model you have, you want to reorganize it a bit such that the input is the production and the output is the price. So you have the transfer function between production and price.
Yeah, because at this point there really isn't any storage, so convenience is really a thing. So then how would you quantify that for upcoming years?
The convenience yield in your situation is very important. That's the ability to be able to sell it at any time. Super inconvenient.
Yeah, so that's not really there at this point.
Oh, I see. That's
so how do I quantify it if there's no data for that.
But there is, it's just that they can't really think of it, what it is. They just get confused that the thing is turning around all the time. This is an interesting article that I plucked out because there's a famous Nobel Prize winning economist, Krugman, who had written an article that the commodity prices today make no sense, okay? So his name is Krugman, right? He writes in the New York Times. He's got a Nobel Prize. I am not a big fan of him. I think he is, way off, but that's my personal opinion, right?
Okay.
You know, and a lot of economists are way off, at least, but they know it. They don't say stuff about reality, and this guy does, all right? So he says there's nonsense, and there was a future trader who wrote an article saying, well, you know, listen, I can easily explain what's going on because we get variability, right? And he's just explaining that the basis is flipping around and that Krugman doesn't realize that. And his whole article is Krugman is ignoring the convenience yield. Okay? I can forward you the article, it's pretty interesting, okay? He says, the guy just thinks of the cost of carry and he's ignoring the convenience yield, all right? So he's, from our perspective, he's ignoring the imaginary part of the solution, right? Okay, of the rate. So he then goes ahead and he makes this analysis and he says, you see, you know, it's just, it's called, the market is inverting. They call it an inverted market and then reverting and inverting. Huh? Now, usually what happened, especially in the old days, is that the other cost of calories were so high that you always had these overdamped systems. So they would have only very small reversions, all right? I have a bunch of other graphs that I ended up not doing in here, you know, but you can see, maybe at this point I should have put it in, but I can send you this later. What?
I have an idea how to solve your problem.
So if you add damping, you will see that, suppose you go over here, you probably guys all know this. What happens if you add a lot of damping to this thing? Well, first it will kind of go like this, but at a certain point it won't even make it. It will just go, you know, like this or something, right? It won't even make a cycle. Then is when it's overdamped. That's what I believe it will do, right? Yeah. Huh? So if you leave, let's go here. I think it will just.
Yeah, it goes to the 45 degrees.
So like this, right? So it will just go on and on. Huh? So you will have no oscillation, so you won't have to worry about this convenience yield so much. So you can kind of pretend that everything is, you know. When you're critically damped, of course you can pretend that you don't have any. It's very easy to pretend that you don't have any fluctuations because a critical damped system has no overshoot and doesn't have this kind of undershoot either. Okay, huh? The solution is just an exponential. Okay, so I think in the past that's what has been happening. You know. There was so much cost associated with financial transactions that the thing is highly overdamped or at least critically damped, you know, where you can kind of get away with ignoring the convenience yield, just throwing it on. But then in the 20s and the 30s, Keynes and Hicks, and also after the war, they started saying, hey, there's something more. All of a sudden, the thing is trading in contango. You see, if you have enough damping, it's always in backwardation. That's what they call normal backwardation, you know? You don't have any problems. The thing is just, you know, but otherwise you're going to find, then it would go into contango and it will switch around as transaction costs were going, then you get these problems. And now these problems are getting bigger and bigger and bigger, you know? But our financial markets, they're just characterized by big fluctuations. You know, we go from credit crisis to credit crisis, you know. Then the credit crisis, then there was a dot-com bubble, and all these bubbles, you know. So
it's probably also because of the speed of information. So in the early days, the information about the demand was very slow, so you could easily adjust your production to the demand. So you didn't need any buffers. Also, right now in electricity markets, you can just turn on your generator to give the demanders what they want. But when you get renewables, then you don't have that option anymore. And if you don't want the prices fluctuate heavily, you can calculate or design how much storage you need.
Yeah.
So it becomes more of a design question than identification.
Yeah,
Yeah.
That's probably what you meant by solving this problem.
Yeah.
Because I was thinking of the same thing of the controller you designed, where the K was actually a control factor.
Yeah. Yeah, now in this case it becomes a design factor.
Yeah, design instead of control. Yeah, you're right. Anyway.
See, this is of course there's an error here, right? There should be a minus sign here. This is something that's hard to see for economists, is that a want or economic force causes an extension of the demand rather than just, a level of demand, right? So this is what Newton told us, so the convenience yield will make you go and accelerate up the stocks or down, all right? And this is what causes cycles, So you got inertia in the system. They call that price momentum. It's an awful term. But the price has a tendency to keep going and going up because of these effects, okay? Now these momentum traders and all of this. So this is a key part, so that this convenience yield is proportional to the extension of the demand, not to demand itself. Okay? And then what you get as a result are these sine waves, and this is the price, and this will be the stock or the basis. They move simultaneously. Okay. Now this was just the future markets, but you can look at the entire economy, like something that Gilbert did or something, and they do that too. So they look at GDP, that's more like a kinetic energy, and they just look at GDP, all right? So GDP will be the kinetic energy. So you would think if GDP is constant, that you will just be cruising along here, I suppose, right? So this will be your price, the zero price level, which is just a market price. But you don't. You sit and cycle around there, and nobody really sees where this thing comes from. They call it the business cycle, and I believe they identified 4 cycle, the Kuznets cycle, and a bunch of Russian names. Kirillov cycle, and then Wikipedia, the article has them all, as well. I plucked this thing out. And so the entire economy seems to move in this way, all right? And Keynes had already analyzed it, and he came with this idea that there was something called a desired inventory level here, right? So this is the point where you have everything is at market price, and all inventories are at the desired level, right? So there's no convenience yields, okay? And there is no extension of the demand, right? No changes in the demand, all right? So now you're at a total equilibrium, right? And you're just cruising along like that and everybody happy, all right? Well, what happens is the economy seems to move between what they call a peak, when prices are high, right, to a trough when prices are low and we're in depressions, all right? So they identify 3 phases. So this is this boom phase with high prices and everybody, a lot of volume going on, right? And then the recession phase when everybody has to pay back their debts and it gets really nasty and volumes go down, right? So the Q dot is 0 here. Demand dries up, right? Then the depression where everybody is just, dumping everything, and then a recovery again, all right? Boom, and this is what they call a trough. There's a depression. So you can see they give it these colors. I guess the other one I gave it the wrong colors, but this is how you would want to see it. So this is when the economy is expanding, and this is when it's contracting, right? So it's going through those phases. Now, of course, it doesn't really do this, it does all kinds of stuff, but nevertheless, this is the picture that you will just get out of a simple article. You can look it up, like the business cycle, and you see all kinds of popular things and explain it, all these different cycles. What's very satisfying is you can just plot it in the phase plane, and it's pretty clear what's going on. Okay? Yeah, I didn't want to do this. So,
And then the whole thing is also growing, so it's actually moving apart or not.
yeah, so now you have you can imagine all kinds of other things, right? So we have, this is just what you get when you get only two things. So there's demand and there is scarcity of resources, right? So here are your resources and there's scarcity. And the way you measure the value of that scarcity is through the convenience yield, right? So the nastier the scarcity is, the higher the convenience yield of holding these things. You know? So this is not so crazy. A lot of economics is about only these two things, right? And then maybe some inefficiencies, right? Because they're about efficient allocation of these resources. So, all right? That's the R element. We are not there yet, all right? So, what was your question?
So it's actually also going, the overall movement is diagonally upwards. Right?
Oh, you're saying this thing can go up like that, right? Yeah, you could. Or it can go contract inwards like that, right?
Yeah, but over a long period of time it's probably expanding.
Typically, it expands.
Yeah. Right, but what's going on there is that you're increasing the amplitude, right? Or you're pumping energy in the system. So this thing is going to preserve the surplus, right? So at this point, it's got all, this will be the surplus, right? So this is what you would call your operational surplus. This is just the stuff that's being bought and sold. But here, the surplus is the same. It just happens to be in, everybody being short, and therefore having a lot of desirable stuff that they are renting out, okay? So this is what you could call the potential surplus. So this is the operational surplus, or OPEX, or whatever they call it. I don't know what they call it, right? And this will be the potential surplus. So that surplus, or economic rent, that can be translated into economic activity, all right? And this is, of course, conserved, as is what we proved last time, right? So in the cycle, well, the business cycle is just the only way, if you don't have any damping or growth, is the only way the system knows how to, conserve the surplus. It just has to pass it in between inventory stocks and sales, okay? That's just what happens. Now, this is what every business does. So you buy, put it in inventory, and then you sell. And then you buy, and put it in, sell, right? Out of inventory.
So then the only way this can expand or extract is when cash flow is injected into the system, of course, the energy level.
Yeah. And how can it contract? When you put it in R elements, for instance, then it goes out, and it goes in these other degrees of freedom, right? So you start paying for your warehouse, but where's the queue for the warehouses? It's not here, right? So slowly you will be, but if you don't take out too much, the thing will actually keep cycling up and down, and this thing will start looking like that, right? Okay. But if you're doing business and people are putting money in and investing in your economy, then the thing will spiral out. Sure?
Yeah.
Huh? And if you're doing nothing, but you're not dampening, a totally efficient market, the only way it will know how to sustain the level of activity is to go through the cycle. You can't erase it, you see? The only way to erase it is to take this out and put it back there, okay? You have to accept the oscillations as part of the way the system achieves equilibrium, just like a spring mass system. In the end, it's going to minimize its Lagrangian, and it's just going to say, well, here's what it's going to say. Well, look, I just don't only want to sell stuff, I also want to have stuff, right? I just don't always want to have stuff, I also want to, buy some stuff again, you know? So what it does, it kind of balances the amount of selling and buying activity from with the storing, okay? And this is the Lagrangian. Huh? And ultimately, that thing will end up saying, well, then you have to move in this way. Of course, we didn't show it like this. This is more of a reason to reason why we'll be doing it. What we showed is that if the law of demand is valid, and if the law for convenience yields is valid, the theory of storage is valid, then the system has to go in here. Not because, right, I didn't, that's weird. Oh,
it's all crashing.
oh, is it crashing? Yeah. Well, this is just some kind of maximization thing, and we haven't done that yet. We'll do this later. But what you're going to see is that this is the law of demand, okay? And this thing here is what's called the theory of storage, or the convenience yield theory. And if these two are valid, you know, now then the system will move this way, all right? So if stocks give a convenience, and if you can sell them at the same time, the goods, then, and that's all that's happening, then the system, now depending on K&M, it may go to an ellipse or something like that, right? Yeah? Okay. But that's the upshot here. So I don't want to get too much lost on Lagrangian stuff yet, but you just have to see that just by two things that are generally accepted as being complete truths. The law of demand is just valid, all right? There is some end for which this works, you know? And the storage is also valid, the convenience yield. They've seen it on commodity markets, it's there. If Krugman says it makes no sense, somebody else can say it does make sense, okay? It's just the case. People like to have stuff in storage, you know? It's just the case. You like to have a vacuum cleaner because you can use it. You pay for the use of it over time, you know? So, so from that follows this, okay? Now that is something that in engineering you can say from Newton's law, which is this one, and you know, this the spring law, the potential force, it's called the potential force then, this is a generalized spring law, this one comes the harmonic oscillator, you know, and the system has no other option than to just oscillate forever, okay? That's it. The significance is that this is a movement that is easily not seen because of the way this works, right? So if you differentiate this thing and then you can plug it in, you will see that what's happening is that the convenience makes you want to increase your purchases, you know, not buy more, but increase your purchases. Understand the difference? Buying more just means I bought an extra loaf of bread, but increase my purchases. Instead of 1 loaf a day, I'm buying 1.5, all right, per day, okay? This is a critical difference, right? So you're changing a flow variable. This is easy to miss. And it's missed by economists like Krugman. I mean, there's a Nobel Prize winner, the guy who's on the future markets, they know better because they lose money if they, you know, these prices are there for a reason because the people who can't do it, they lose money. Church, you had a question, I see, finally. Huh?
Yeah, the business cycle. Are we talking about years or decades or months?
Yeah, so
There are multiple.
They're multiple. They call them different names, right? So there's, I think if you look it up, there's the Kuznets cycle, one called the Kuznets. And then there is a Lifshitz cycle or
Inventory cycles.
the investment cycle.
Yeah, also inventory cycles.
And then there's an inventory cycle, and there's a bunch of other cycles.
Okay.
One of them claims that I think one of these periods is 2 months. One of them, I think, is the Kuznets cycle.
Oh, okay.
Yeah, I think they're really 3 months and then you just get that, right? Huh? They're very fuzzy, and then there's a discussion on which cycle there is. Huh?
I think the one they typically call the business cycle is 5 to 8 years or something.
Yeah, type it in on Wikipedia. You're behind your computer, I'm sure you are, since you're staring at the camera. Type in Wikipedia business cycle or something. And tell us what you see. So you see all these different cycles? Huh?
It was a very long page.
Anyway, yes?
Yeah.
But they have all different ones. And why not? I mean, the economy, you could think of it as one mass with a spring, that there's just one basket of goods. But usually they'll think of investment goods as being different from consumer goods. So one they would call the investment cycle, you would look at it, and the other they call the inventory cycle, right? So they'll just have 2 oscillations, right?
Yeah, I see here also one that's 60 years.
60 years, there you go. Huh? You know, I mean, those have to do with population growth measures or something, right? So the amount of labor available seems also to go up and down. So, for instance, in the Roman Empire, they had these depressions after the plague. You know, you had what's called the Antonine Plague. It was during the Emperor Antonius. And then it kills a lot of people. So then you'll see that the labor force goes down, you know, and that causes another cycle. Then they have another big plague in the Middle Ages. And, you know, now, I don't know, that's a few hundred years cycle, you know. So you can just look at what product, what queue you're looking at, the stock of labor, or is the stock of capital goods, or is the stock of consumer goods, you know, and all of them will have a cost of storage, right? And will have their own cycle, I would assume, right? And what are you, and then you throw all of them together in one big fat basket, you know, you're going to see some different variability. Huh?
It's only a market with perfect information you would be able to completely flatten out.
No, how would you do? Yeah, you would be able to.
If you would have perfect information.
Yeah. So what's different with this system? And you give it a whack. This is going to go up and down, right? Now, if you have perfect information, you can apply a force so the thing is standing still. Yeah, sure. Yeah.
If you can apply force.
If you have enough force to do so, right? You may also wonder whether you can stop the entire world economy with your, huh?
So I mean, if you would know exactly when someone would demand something, you wouldn't need any stock. You could simply offer it at the very moment they would want it, in case you would have perfect.
Yeah, but the problem is,
no, but you need
it's
also
like commodities that take time to, like crops, they grow once a year. So there's a problem already.
You need not more than perfect information. You need perfect delivery, perfect production. You need stuff that just doesn't exist. And then you need masses of zero, that helps too, right? Springs.
But just for my own idea, that would flatten out the cycle.
Yeah, theoretically.
No, it's not just information. You also.
But if everything was so, it is theoretically possible.
Yeah, but perfect information is not enough.
No, it's not enough. Yeah.
You know, you need also perfect delivery. I mean, how do you get this thing to stop vibrating, right? Well, you just say there's masses around, there's no demand. So that's an economy where nobody's demanding anything. Okay, I've solved it, right?
It's just vibrating infinitely fast. I mean,
no, it's just you give it a whack and this is going at a huge speed, you know, but there's no scarcity, so whatever, right? So I take away the spring, right?
Yeah.
You know, I take away the mass. So I have no storage of goods and I have no demand. So I have no scarcity, I have no demand. There's a definition of economics that says, well, you need at least some scarcity and demand in order to have economics. You just don't have any economics. So I think oscillations are just part of economics. I think if you put it in a damping the thing, well, yeah, you will get off a movement like this or something, you know? And I guess a lot of these older economies, they had a lot of damping. You know, the Roman roads were better, but before the Roman roads, it really kind of sucked. You know, you couldn't transport goods. And then people were just living at the subsistence level. So there's no trade. You have to go back more than 12,000 years ago, where you're just a bunch of hunter-gatherers. And even then, they are plentiful. I think it will be hard. And the question is, do you really want this? I mean, this is just the way the economy works. This is how business works. What's the problem? It's just more economic to store things, to borrow rather than to sell. That's the way the market deals with it, So when we do the Lagrangian method, we'll see that this is actually the optimal way, that this fixation on always stabilizing everything is nonsense. Why not have a price variation? This is the whole point. Right? Okay. I ended up going over time, which I wasn't planning to do. So we'll stop here. Then Thursday we'll have a very busy section. So we'll have the Rabobank contingent giving some presentations, since they have a big presentation coming up on Friday. And we have Rumer giving his midterm practice midterm. So Rabobank has an hour.